Now let us understand the concept of derivative here. I have my function y is equal to fx here. Uh, my xy plane, my coordinate axis x and y, its origin here. Now I have this point A here and point B here. Point A is x1 comma y1 and point B is x2 comma y2. Okay. Now these points A and B, they are on the curve. So I can say that AB is my secant. Okay, now what is the gradient of secant? Gradient would be, obviously it would be y2 minus y1 upon x2 minus x1. Correct? So this is y2 minus y1, that is change in y, and x2 minus x1 is change in x. Correct? So I'm going to call this as delta y upon delta x. Correct? Now what I'm going to do is I want to bring this point B closer and closer and closer and closer to point A. What would happen? What would happen to secant AB? As my point B approaches A, or when the distance between point A and point B becomes infinitesimally small, is it really zero? I wouldn't say it is zero, but then if it comes very close to point A here. Now here you can see what are the coordinates of this AB. Let us call this point C and point D here. Correct? So this would be x1 comma 0 and x2 comma 0, and here it would be 0 comma y2 and 0 comma y1. Right? So now as B comes closer and closer to point A, this x2 minus x1 becomes very small, and when x2 minus x1 becomes infinitesimally small, then y2 minus y1, which is delta y, that will also be corresponding infinitesimally small value, isn't it? So then if my delta x tends to 0, then my secant can be approximated as tangent. Now remember the example that I gave in the previous video, example of that rabbit. The distance of the rabbit, the rabbit jumps half the distance, half the remaining distance every second. Correct? So it is going to never reach. Okay. Likewise, this point is going to never reach point A, but still when my delta x takes infinitesimally small value, then that secant can be considered as tangent. Correct? So secant tends to tangent. Then what about this? So then delta y by delta x. Correct? And then that I am taking limit of that as delta x tends to 0. That is called dy by dx. And the dy by dx is called derivative of y with respect to x. So derivative of function y with respect to the variable x, of which y is a function. So that was about derivative. Now suppose we have some exercise here. Suppose my y is equal to x square. Correct? Now let us take some increment in x. Okay, some increment delta x. Okay, which actually tends to 0. Okay, some increment delta x in x. So what would be corresponding increment in y? That would be delta y. Okay, so now y is equal to x square. So y plus delta y is going to be equal to x plus delta x square. Do you agree with this? So now what I do? Now I take something like this. Okay, limit of delta y by delta x as delta x tends to 0. So now what is my delta y then? X plus delta x square minus y, correct, which is equal to your y is equal to x square. So instead of writing y there, I will write x square. And now what do? We have to find something like this, delta y by delta x. So I am going to divide this by delta x is equal to upon delta x here. Now what? Now I am taking limit as delta x tends to 0. So limit as delta x tends to 0, delta y by delta x is equal to now here what is my delta x? Is it not x plus delta x minus x? So again it is gradient. Okay, so now if I expand this, so now that is again limit of limit as delta x tends to 0, x plus delta x square. Let us expand this, so that would be x square plus 2x delta x plus delta x square minus x square, and then this divided by delta x. Now here this x square is gone. This delta x is infinitesimally small. Okay, now take this example, 0.1 multiplied by 0.1 square, it is 0.01. It is, if I have 0.01 square, then it would be 0.001, isn't it? So if my delta x is infinitesimally small, its square would be even small. It would be very, very small, almost equal to 0. So I will ignore this delta x square. Okay, but I am keeping this 2x delta x as it is. So now what I am left with here, it is limit as delta x tends to 0. So it is 2x delta x upon delta x. Correct? Can I cancel this delta x on numerator, in numerator and denominator? I can do that because see, my delta x is not equal to 0. Okay, delta x tends to 0. Delta x tends to 0 doesn't mean that delta x is equal to 0. Correct? So what am I left with? So that would be limit as delta x tends to 0, 2x. So finally my answer is going to be equal to 2x. Correct? So now I am going to write here. I am using different color because I don't want to rub this out at this point of time. So maybe you can just look over here. So y is equal to x square dy by dx is equal to 2x. As we did here for y is equal to x square, we can prove that for y is equal to x cube, dy by dx would be equal to 3x square, and so on. So if my y is equal to x raised to power n, my dy by dx I can prove that it is n into x raised to power n minus 1. This is my general formula. For any algebraic quantity or any algebraic function, y is equal to x raised to power n, where n is a real number. Okay, I can say dy by dx, derivative of that is n into x raised to power n minus 1. So that is how we generalize that. In the next video, we are going to talk about derivatives of trigonometric functions and other functions for it. Thank you so much.